One moment, you're looking at a star. The next, you're being stretched into a cosmic spaghetti noodle. For centuries, black holes were the stuff of science fiction, lurking as cosmic boogeymen in the darkest corners of space. But thanks to incredible breakthroughs, we now know these gravitational behemoths are very real, scattered throughout the universe, some even at the heart of galaxies. Today, we're not just theorizing, we're taking a hypothetical plunge into the ultimate cosmic abyss, a black hole. What really happens when you cross that point of no return? And what would your final moments truly be like? Prepare to have your mind bent, because the physics inside a black hole are weirder than anything you could possibly imagine. Let's set the scene. Imagine you're a brave or perhaps incredibly reckless astronaut, drifting closer and closer to a black hole. From a distance, it's an invisible predator, a perfect sphere of absolute darkness against the starry canvas, its presence only betrayed by the way light bends around it, like a funhouse mirror. The first thing you'd notice, even before you felt anything, is the extreme warping of space-time. Light from distant stars would appear distorted, stretched, and even multiplied as it gets bent around the immense gravity of the black hole. You're approaching the event horizon, the most famous boundary in the cosmos. This isn't a physical wall or a visible line. It's a boundary in space-time, a point of no return where the escape velocity, the speed you'd need to get away, exceeds the speed of light itself. Once you're inside, not even light can get out, which is why we call them black. Now, here's where things get tricky, because what happens next depends entirely on the type of black hole you're falling into. Most people think of black holes as all being the same, but there's a huge difference between falling into a stellar mass black hole, one formed from a collapsed star, and a supermassive black hole, like the one at the center of our Milky Way galaxy. This distinction is critical because it dictates your immediate fate. Let's start with the more dramatic and perhaps more commonly imagined scenario: falling into a stellar mass black hole. These typically have masses a few times that of our Sun, but are incredibly compact. As you approach the event horizon of such a black hole, the gravity isn't just strong, it's uneven. The gravitational pull on your feet, which are closer to the black hole, would be significantly stronger than the pull on your head. This difference in gravitational force, called a tidal force, would stretch your body like taffy. Scientists have a wonderfully descriptive, if slightly horrifying term for this: spaghettification. Your body would be elongated, pulled apart atom by atom, into a long, thin strand of matter before you even cross the event horizon. Bones would snap, muscles would tear, and the very fabric of your being would unravel under this impossible strain. From an outside observer's perspective, however, your descent would appear to slow down dramatically as you approach the event horizon. Your onboard clock would seem to tick slower and slower, and your light signals would be redshifted, becoming fainter and redder until you simply freeze and fade from existence, a permanent ghost-like imprint on the edge of the abyss. But what if you were falling into a supermassive black hole? These monsters can be millions or even billions of times the mass of our Sun, yet their event horizons are much larger. Because the event horizon is so vast, the gravitational gradient across your body is much gentler. In this scenario, you could actually cross the event horizon without feeling anything unusual at all. No spaghettification, no immediate tearing apart. You would simply pass that invisible boundary, unaware of the profound change. From that moment on, you are inextricably linked to the black hole. The direction forward no longer points away from the black hole, it points into it. There's no turning back, no possible escape. You've stepped into a realm where the laws of physics as we know them are twisted beyond recognition. Once inside, whether you were spaghettified before or slid through unnoticed, your journey continues towards the black hole's ultimate mystery, the singularity. This is the theoretical point at the very center of the black hole, where all its mass is compressed into an infinitesimally small volume, and gravity becomes infinitely strong. What happens at the singularity? Our current understanding of physics completely breaks down. The equations simply don't work anymore. Some theories suggest you'd be crushed into oblivion, merged with the black hole's core. Other, more speculative ideas propose a portal to another universe, a tear in the fabric of space-time, or perhaps a reversal of time itself. For now, the singularity remains one of the universe's most profound enigmas. It's the ultimate end, or perhaps the ultimate beginning, a place where our imagination runs wild, but our science falls silent. So falling into a black hole isn't just a simple descent. It's a cosmic ballet of warping space-time, extreme gravity, and the total breakdown of familiar reality. Whether you're stretched into a ribbon or slide into an unknown fate, one thing is certain. It's a one-way trip to the most extreme environment the universe has to offer. It's a reminder of just how much we still have to learn about the incredible, terrifying, and utterly mind-bending nature of our cosmos. If you want to unravel more of the universe's biggest mysteries, click on the video popping up on your screen right now.